Now, question number 14 through 17 have to do with this little diagram here. So this is the whole titration curve. A 50 ml sample of an acid, HA, of unknown molarity is titrated, and the pH of the resulting solution is measured with the pH meter and graphed as a function over time of the volume of 0.1 molarity sodium hydroxide is added. Now, sodium hydroxide, notice, is a strong base, and that is why as you go all the way to the right, it's reaching a very high pH of about 13, a little above that. Well, you can only get that if you have a strong base. Now, another thing I want everybody to notice is if you take a look at the equivalence point, it's sitting at 8, right? So what does that indicate? This HA must be a weak acid. Remember, wait, why is that an indicator? Because if you were to have a strong acid, if you had a strong acid to begin with, and you're titrating that with a strong base, think about it. Strong acid and strong base. They're both strong. So if they were to titrate, aka like neutralize each other, well, it should do so at a pH of exactly right down in the middle, 7, not 8. The fact that equivalence point is already at 8, above 7, should indicate that the acid was the weak one and the base was a strong one. So given that, let's take a look at the questions. Number 14. At point R in the titration, which of the following species has the highest concentration? Point R is right there, right? And that's quite not at halfway through the equivalence point. Remember, the equivalence, the titration happens at 40 mil, and the 20 mil, we call that half equivalence point, right? So that's half equivalence point. So point R, we're not even at the halfway yet. So what does that mean? Well, if we have this HA dissolving into H plus and A minus, of which this one, the OH, is consuming it, well, not much has happened just yet. So if I were to kind of give you an idea, like if we started with 100 right here, well, doing that little ice chart, does everybody remember? And that's the initial change in equilibrium, right? Imagine you had nothing, nothing. At point R, once again, we're not even like halfway. So I don't know, maybe like you lost 30 of it. And then so therefore you gain 30, you gain 30. So you have 70 and 30 and 30. And once again, that 30 is probably gone because the hydroxide keeps consuming that H plus as it comes out. So what do you have the most of? The HA it is.